Everyone, this is Vijaya Vandita. I am from Sri Venkateshwara College of Engineering. I am studying in third sem in the branch CSE Data Science. I am from the college Sri Venkateshwara College of Engineering. Today I'll be discussing on the subject mathematics for CSE stream. Let's discuss on the concept basic principles of ANOVA. Let's see what is ANOVA, its basic principle, its type, its operation, its technique, its formulas, its charts, everything in detail. The basic principle of ANOVA is the test for a difference among the means of the population by examining the amount of variation within each of these samples. So ANOVA is the test for difference among the means of the population relative to the amount of variation between these samples. In the terms of variation within the given population, it is assumed that the value of x of ij differ from the mean of this population only because of the random effects. The meaning of this is there are influences on x of ij which is unexplainable. Whereas in examining difference between population, we assume that the difference between the mean of jth population and the grand mean is attributable to what is called specific factor or what is technically described as a treatment effect. Using ANOVA, and while using ANOVA, we need to assume that each sample from a normal population and that of these populations have the same variance. So while using ANOVA, we need to check that these populations have the same variance. We also assume that all factors other than the one or more being tested are effectively controlled. So we need to assume that all the factors that the one or more being tested are effectively controlled. This is very important while performing with ANOVA. We further assume that the absence of many factors that might affect our conclusions, considering the factors to be studied. In short, we have to make two estimates of population variance. One based on between samples variance and the other based within sample variance. Then the set two estimates of population variance are compared with the F-test wherein we work out. So F-test is the main concept in ANOVA. So F is the estimate of population variance between the sample variance divided by estimate of population variance within sample variance. The value of F is to be compared to the F limit of the given degrees of freedom. If the F value we work out is equal or exceeds the F limit value, we may say that there are significant differences between the mean sample. So F represents the degree of freedom. Let's see the techniques which we use in ANOVA. The first one is to obtain the mean of each sample. That is, we need to obtain the means of each sample. To obtain the means of each sample, where x1, x2, x3, and till xk are the samples. There are k number of samples in the mean. Next, we need to work out with the mean of the sample means. Third step, take the derivations of the sample means from the mean of the sample mean and calculate the square of which deviations which may be multiplied by the number of items in the corresponding sample and then obtain their total. This is known as sum of square of variance between the samples. So first we need to calculate the square of the derivation, then multiply the number of items in the corresponding sample. Then we'll get the total. That is called as sum of square of variance between the samples. Next step is we need to divide the result of the third step which we have performed. That is sum of squares we have performed with the third steps, right? That we need to divide with the result. Variance of mean square between samples, symbolically it can be written as MS, where k minus 1 represents the degree of freedom. Next step, we need to obtain the derivations of the values of the sample items for all the samples from corresponding mean of the samples and calculate the squares of such derivations and then obtain their total. This total is known as sum of squares. For variance with sample, symbolically it can be written as. Next, we divide the result of step 5 which we have performed before, that is degree of freedom, with total variance of mean squares within the sample. Next step, for a check, the sum of squares of deviations for total variance can also be worked out by adding the squares of the deviations when the deviations for the individual items in the samples have been taken from the mean of the sample means. Symbolically, we can be written as total should be equal to the total of the result of step 3 and step 5, which we have explained above. So the total should always be the result. SS for the total variance is equal to SS between plus SS within. That is sum of squares of total variance. We have the formula sum of squares between plus sum of squares within. Next, the degrees of freedom for total variance will be equal to the number of minimum samples, that is n minus 1. N is the total number of samples. Degree of freedom we can calculate as total number of samples, that is n minus 1. The degrees of freedom for between two variants upon the degrees of freedom for total variance, that is the formula n minus 1, which is total variance minus 1, equal to k minus 1 plus n minus k. K is number of samples. This effect explains the additive property of ANOVA technique. Finally, F ratio can be worked out. This ratio is used to judge whether the difference among several samples means is significant or is just a matter of sampling fluctuations. For this purpose, we look into the table given the values of F for given degree of freedom at different levels of significance. So let's see if the worked out for value of F as stated above is less than the table variance difference is taken as insignificant due to the change and the null hypothesis. Difference between sample means stands. In case the calculated value of F, that is F ratio, happens to be either equal to or more than its table value, the difference is considered as significant. And according to the conclusion may be drawn. So according to the value of F, the conclusions for ANOVA can be done. Higher the calculated value of F above the value of table, the more definite and sure one can be about the conclusion. So the entire values depends upon the F ratio and the table. Setting up analysis of variance table. For the sake of convenience, the information obtained through various steps stated above can be put under ANOVA table, one-way ANOVA table. This is the table with N number and F, SS, that is sum of squares. Here in the first column, we have source of variation. Second column, we have sum of squares, which is denoted as SS. Next column, we have degree of freedom, which is defined as DS. In the third column, we have mean of squares, that is MS. Last column, we have F ratio. Here we have between samples of categories, which is denoted as K minus 1, SS between, which is denoted as K minus 1, MS, which is defined as mean squares. You can just pause a video for 1 minute and just go through this table. This is very informative table. It is very important for one-way ANOVA. You'll get the entire theme and content from this table. I hope you have understood with ANOVA techniques what is ANOVA, its principles, etc. Just watch the table for a minute. Thanks for watching. Hope you have understood the entire video. Please like, share, and subscribe my YouTube channel.